Applied geometry friends, welcome back again to another online video of where we are going to be continuing in chapter 10. Just want to give a shout out to everybody that has been using these videos, been doing what you're supposed to be doing at home, been spending time on the Math Excel assignments, been doing your stuff. I know that this has been a difficult, trying time for a lot of us. Just want to say that I'm proud of you. Thank you for sticking with it. Hopefully you are staying healthy, staying active, and hopefully you're finding these videos and this information helpful, at least to the point of keeping you thinking mathematically. So again, thanks all y'all. Kind of miss seeing all your guys' faces. Come and say hi to me next year because I'm not going to be able to say goodbye to you as I normally do to my students. But 10.3. Areas of regular polygons. Big idea here. The word regular. When you're talking about a polygon is a straight-sided enclosed figure. Any object that has straight sides and it closes in on itself. Like if I just drew this weird wonky donkey thing here, okay, that I was supposed to get there, boom, there you go. It has straight sides and it closes on itself. That is called a polygon. But the big idea of a regular polygon is that regular polygons, all of the sides are equal. Every single one of the legs, every single side of the shape are equal to each other. So regular polygons terminology. You have a center of the regular polygon. You have a radius of the regular polygon. So you could always draw a circle around a regular polygon, and the radius of it would go from the center to where the point touches the circle on your shape. And here's one of the most interesting words in math. People pronounce this a lot of different ways. A lot of people like to call it the apothem, but actually it's called the apothem. This is the apothem of the polygon, the apothem. I know that's kind of a funny word and it's kind of fun to say, but it's the apothem, okay? So first thing, just talking terminology, just looking at this shape. The figure at the right is a regular pentagon. Pentagon means 5 sides. It is a pentagon, but it is a regular pentagon, which means all of the 5 sides are equal, with a radii and an apothem that is drawn. What is the measure of each numbered angle? All right, so here is big idea for this stuff. We are looking for the measure of all of these different angles. We have angle 1. Now, angle 1 is this angle right here. That angle right there is angle 1. We have angle 2, which is inside of this. It's this little distance right here. And then we have angle 3, which is down over here in the corner. Here's big idea. If we travel all the way around, whoop, whoop, what did we just create? Well, we created a circle. What would that circle be? Well, that circle would be 360 degrees. But here's the main idea. Since this is a regular pentagon and all of these sides are equal, all of these radii are also equal. If all of these radii are equal and all of the sides are equal to the sides and the radii are equal to the radii, that means every one of these angles is equal as well. So we have 1, 2, 3, 4, 5 angles. Those 5 angles all divide into 360. They all add up to 360. So then all you got to do is take 360 and divide it by 5, and you get 72. So we know that every one of these is 72. This angle is 72, this angle is 72, this angle is 72. All of them are 72. So what does angle 1 equal? Well, the measure of angle 1 is equal to 72 degrees. The measure of angle 1 is 72 degrees. Now here, we're going to focus in more on this triangle right here. Okay, we're going to bring that triangle down. We're going to rotate it a little bit as well. We have a triangle that looks like this. Okay, we know that we have the apothem that comes down and meets the other side at a 90-degree angle. This angle in here is called angle 2, and this angle in here is called angle 3. So we need to find angle 2 and we need to find angle 3. But we know that this entire thing is 72. That entire angle right there is 72 because that entire angle is angle 1. This side equals this side. The radii are all equal. So this side equals this side. If the two sides are equal and we have this side which comes down at a right angle, we have a rule that that apothem cuts this angle in half. So angle 2 is going to equal angle 1 divided by 2. Angle 1 is 72. 72 divided by 2 is 36. So the measure of angle 2 is 36 degrees. And last but not least, we now have a right triangle where this is a right. We know this is 36. If this is 36 and that's 90, what does this have to be? Well, we know that the angle of measure of angle 3 must add with 36 and 90 to get 180. So 36 plus 90 is 126. 180 minus 126 is 54. So the measure of angle 3 is 54 degrees. All right. We're going to use that later, but now we're going to get to the meat of what we're talking about. And the meat of this is finding the area of regular polygons. The area of any regular polygon is going to be, A stands for area. The area, capital A stands for area. Capital A is area. Equals 1/2 the apothem times the perimeter. The apothem times the perimeter. Okay? That is the equation 1/2 A times P. So, if I wanted to find the perimeter, it is literally adding up all of these side lengths, and then we have the apothem. You might again see that we might have a 30, we have a right triangle in here. We might have to use SOHCAHTOA, special right triangles, etc. All right. Here we go. First example problem. Find the area of the regular polygon to the right. This is our easiest problem because I just tell you that the apothem is 12.3 and that this whole distance is 8. Okay, so the area is going to equal 1/2 the apothem times the perimeter. The apothem, little a, well, that equals 12.3. It literally just tells us 12.3. The perimeter is going to equal, this side is 8, which means this side is 8, and this side is 8, and this side is 8, and this side is 8. You get the idea. They're all 8. Well, how many sides are there? What kind of shape is this? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's called a decagon. There are 10 sides. So the perimeter is going to be 10, the number of sides, times 8, the side length. So then we have that the area is going to equal 1/2 times 12.3 times 80. Half of 80 is 40, and 40 times 12.3 is 492, and that'd be in inches squared. All right. A honeycomb is made up of regular hexagonal cells. A hexagon is 6 sides. The length of one side of the cell is 3 millimeters. What is the area of the cell? So you're going to recognize, let's draw ourselves a picture, but you're going to recognize something right off the bat on this. And I'm not great at drawing hexagons, but I'll try. So these are all supposed to be exactly the same length, right? So that's 3 sides, and then I have 3 more sides. That wasn't too bad. But remember, all of these are equal to each other. They're all exactly the same side length. There's 6 of them, okay? Their length is 3 millimeters. Well, that helps us find the perimeter nicely. We know that the area is going to equal 1/2 the apothem times the perimeter. The perimeter is going to be 6, because it's 6 sides, a hexagon, 6 multiplied by 3, which the perimeter is then 18. I can plug 18 in. A is going to equal 1/2 A times 18. Half of 18 is 9. But here's where we're at now. The area is going to equal 9 times the apothem. But I don't have the apothem. They did not tell me what the apothem equaled. Up in this problem, they just told me the apothem is 12.3 and the side length is 8. All I know here is that the side length is 3. How do I find the apothem? Well, first let's draw the apothem. Here's the apothem. You come straight down at a right angle. That is your apothem. We are going to have to use the fact that this is a right triangle to find the apothem. So here's where we go. That's where this original problem comes into play. Why did we spend time asking this original problem about the angles and everything? Because we're going to have to do this in order to find the apothem. If you didn't pay attention to anything else, I hope you're watching now. This is the most important thing, okay? How do I find the apothem? I need to first figure out what this angle equals. So this angle all the way around would be 360. But how many of them make up the 360? Well, this, if you recall, is half of the big one right here. It's half of it. So if there would be 6 big ones, there's 12 of these littler ones. So I'm going to take 360 and I'm going to divide that by 12. 2 times the number of sides there are. 360 divided by 12 is 30. Wait, 30? 30 degrees? So we have a triangle here. I'm enlarging it. This triangle is now this triangle here, okay? I have a right triangle where this is my apothem, and this angle up in here is 30 degrees. Wait, a 30, 90, oh, wait, what's that got to be? 60. It's a 30, 60, 90 triangle. Do you remember anything about a 30, 60, 90 triangle? I hope you do, okay? This is the short side. What is this distance? Well, if this entire distance is 3, this distance is half of 3. It is whatever this whole side was divided by 2, 3/2, or 1.5. How do I go from my short side to my long side? You take what your short side is and you multiply it by the square root of 3. So the apothem is going to equal the square root of 3 times your short side, which is 3/2. Plug that in. A is equal to 9 times 3/2 times the square root of 3. 9 times 3 is 27. Square root of 3, all divided by 2. That would be your exact answer. If you wanted to, you would take that and plug it into your calculator. Take 27 times the square root of 3, divide it by 2, and you get an area that is approximately 23.38. 23.38, and that would be millimeters squared. Now, go back. How did I find the apothem? Let me draw that again, okay? You have your 6-sided hexagon. This one's not going to be as good because I'm drawing it a little faster. And it's still decent, okay? I need to find out this angle right here. Let's call it x. I need to find out x. But if I was to draw out every one of these triangles, if I was to draw out all of the radii of this hexagon, and then I was able to cut them all in half by drawing all the apothems. Every line I just drew there is an apothem. Every one that comes down at a 90-degree angle is an apothem. Okay? Every one of these is x. Every single one of these angles is x. How many angles are there that create the entire circle here? Well, there's 12 of them. I took 6 triangles and I cut them in half. So 6 cut in half, right? 12 of them. You multiply it by 2. 6 times 2 is 12. So you take the circle of a 360-degree circle and you divide it by 12, which gives you your 30. And that gives you then a 30, 60, 90 triangle. A 30, 60, 90. And the rules of a 30, 60, 90 is your short side, the long side here is your short side multiplied by the square root of 3. The long side is the short side times the square root of 3, and your hypotenuse is 2 times the short side. But for this problem, we didn't need to use that. We just needed to know what the short side was. The short side is half of what the entire distance is. Half of 3 is 3/2. So therefore, A is equal to the square root of 3 times the short side. Plug that in for our equation here for A. Simplify it down. 9 times 3 divided by 2 times root 3. Done. This one is a little harder, I know. This one is going to be the one that's going to give you guys some problems if you have any issues on it, okay? Take some time, look at this problem, redo this video if you have to. That is how you find the area of a regular polygon. The apothem times the perimeter divided by 2, or 1/2 the apothem times the perimeter. All right, everybody. Stay safe. Get this work done by Friday at 8 p.m. It'll be available, today's Sunday night. It'll be available tomorrow. Hope you guys are all staying healthy and safe. I wish I could see you guys, but not at the time, huh? So have a good evening. I'll talk to you again. Bye.